Hi there. Today we're going to talk about scientific notation. It is something that is very commonly used by scientists and mathematicians. Okay, and it is also known as the standard index form. Standard index form, or it can be also known as standard form in the UK. So you got to be careful here. When we talk about standard form in our presentation, it's gonna mean something else, not scientific notation. Okay, and so where do we use it for? So for example, let's look at the world population. Do you know what's the world population? Make a guess. All right. If you got it right, yes, it's at about 7.6 billion. So if we look at 7.6 billion, so the world population is currently at 7.6 billion, but I'm going to use 7 million for convenience. So it's 7 billion, okay? So maybe let's look at it from a couple of years ago. So 7 million, we're going to write it as, if you remember how to write it down, will be 7. How many zeros would it be after that? So let's see. So this is 7 million, so I want 7 billion, so I will have to write 3 more zeros. So this is 7 billion, and this, in this number, this form, we're going to call this the standard form. Okay, so this is a standard form of the number 7 billion, and we can see that it is very inconvenient to write this large number over and over if you're going to write it on the report or mention it in an article. So a very easy way to, a convenient way to write this number would be put it in scientific notation. So let's look at how we can convert this number to scientific notation. So 7 billion will be the same as 7 times 1 billion. Okay, and look at the number of zeros there. Okay, and we're gonna first convert this number here into 10 to the power of 10, right? So let's see what happens here. If you look at a number here, say if you have 10 to the power of 0, we know that equals to 1. Okay, 10 to the power of 1, that will give you 10. 10 to the power of 2 will be 10 times 10, and that will give you 100. And 10 to the power of 3 will be 10 times 10 times 10, and that will give you 1,000. So you could see you can write it as 10 to the power of a number, and that's determined by the number of zeros in the number. So let's see, this will be 7 times 10 to the power of, we're going to count now. Okay, and this is what I do when I write it in scientific notation. I will count every time. So it will be 10, this is 1, this is 10, 10 square, 10 cube, 4, 5, 6, 7, 8, 9. So there is 7 times 10 to the 9 power. So this is now, this number is now in scientific notation. Okay, scientific notation. And another example I'm going to show you next will be, if you look at a very small number, for example, let's look at the microorganism. Let's say the diameter of the microorganism amoeba. So it is at, amoeba is at I think it's at 3 micrometers. So 3 micrometers is around, if we want to write it in the SI form, SI unit, which is in meters, it would be 0.1000003 meters. Okay, so again, this number, if you want to list it out in its standard form, all right, this is the standard form, or you can call it a decimal form. Okay, standard form. It's going to be inconvenient to write it over and over, so we're going to write it in the scientific notation form so that it's easier for us. So you can see that if I have I draw a line here. So if I look at, if I have 10 to the power of 0, we know that equals to 1. 10 to the power of negative 1, we know that is 1 over 10, and that gives us 0.1. And 10 to the power of negative 2 is 1 over 10 squared, which is 100, and that gives us 0.01. So from here, you could see that this number here will be 0.000001 and multiplied by 3, right? 3 times to give you the 3 micrometers. So, and 3, we will leave it as 3, and this number here can be written as 10 to the power of, let's count out the decimal point. In this case would be, if this is 10 to the power of negative 1, 10 to the power of negative 2, negative 3, negative 4, negative 5, negative 6. So it will be 3 times 10 to the power of negative 6, and this is what we call in the scientific notation form. Okay, so you could see that we have written a very big number and a very small number in the scientific notation form. Now let's look at those two numbers that we wrote earlier. So 7 times 10 to the power of 9, and we have the other number 3 times 10 to the power of negative 6. So these two numbers are in scientific notation, and I'm going to give you the rule for scientific notation. So in for scientific notation, all right, when you write number in scientific notation, you're writing it in the form of a times 10 to the power of n. And this a, which is the coefficient of the factor, has to be between, it has to be greater than or equals to 1, but less than 10. And the n, this number here, has to be an integer. So you could see from the examples, the earlier examples, 7, which is our a, is greater than or equals to 1 and less than 10. 3 is also, greater than or equals to 1, but less than 10. And the number 9 here is an integer. The number negative 6 is also an integer. And this, this will end our presentation on the scientific notation.